Now I will talk about special relativity and the twin paradox. Special relativity is an explanation of how speed affects mass, time, and space. As an object approaches the speed of light, the mass of the object becomes infinite, and so does the energy required to move it. This means, this means that it is impossible for any matter to go faster the speed of light or even reach the speed of light. Now I will talk about the twin paradox. The first twin flies into space at a very high speed, for example 240,000 kilometers per second, and returns to Earth while the second remains on Earth. According to the theory of special relativity, movement at high speed slows down the flow of time. So the brother who went on a journey in space will return to Earth 10 years younger than his brother who stayed on Earth. Now I will describe the paradox broadly. One twin remains on Earth while his brother moves away in spaceship at a very high speed, close to the speed of light. At some point, the brother turns around and returns to Earth. According to the theory of relativity, the journey in the spaceship will take less time than on Earth, which will lead to the brother in the spaceship returning younger than the brother left on Earth. For example, suppose the journey is to the star Epsilon in Eridanos, which is about 10 light years away from solar system. And the speed of the spacecraft is 80% of the speed of light, that is to say 240,000 kilometers per second. According to the twin left on Earth, the round trip time as measured on Earth is T naught equals to 2 times L naught divided by V. L naught is the distance from the Earth to the star Epsilon, equals to 2 times 10 divided by 0.8, that equals to 25 years. So we multiply 10 light years by 2 because the journey is back and forth. He goes to the star and then comes back to the Earth. So according to the twin that stays on Earth, it will take him 25 years all the journey. And according to Lorentz transformation, the time measured by twin in spacecraft is T spacecraft equals to T naught times root of 1 minus V squared divided by C squared is equals to 25 is the time that takes the journey according to from the point of view of the twin that stays on Earth. 25 times root of 1 minus 0.8 squared. This is equal to 15 years. So, because of the fact that the twin that is on Earth watches his twin brother that is moving in very high speed with the spacecraft. So there is time dilation, so it will take him 10 years less than the time that measured by the brother that is on Earth. So that is all because of the fact the time dilation of the brother that is on the spacecraft, because of the fact that he is moving in very high speed, the time is actually the time passes slowly, so it will take him less by 10 years, because the time itself passes slowly because he is traveling in very high speed. So it will take him, all the journey takes him only 15 years. Okay. According to the twin in the spacecraft, he is at rest, while the Earth on which his twin brother is and the star Epsilon in Eridanos are moving across it at a speed of 80% of the speed of light. As a result, the distance between them shrinks according to the Lorentz transformation. So the distance it must travel is L spacecraft equals to L naught times root of 1 minus V squared divided by C squared. L naught is 10, it is the distance between Earth to the star Epsilon, and V divided by C is 0.8 squared. The final result is 6 light years. So in the point of view of the brother that is in the spacecraft, the journey to one side from Earth to the star Epsilon will take him only 6 years. and not 10 years, because the distance shrinks according to special relativity because of the fact that it is moving in very high speed that is very close to the speed of light. So to one direction, from Earth to the star epsilon, the journey is the distance between the Earth and the star epsilon is only 6 light years, because of the fact that the distance shrinks. Distance is not a constant thing, space is not a constant, it's something that is relative. And that is the reason that the distance shrinks when you are traveling in very high speed. So the distance from Earth to the star epsilon is only 6 light years. So in total, the time that it will take the brother to complete all the journey is actually equals to T spacecraft equals to 2 times L spacecraft divided by V. That's equals to 2 times 6 divided by 0.8 equals to 15 years. We multiplying 6 by 2 because it travels in back and forth, yes, at 2 directions. So in one direction is 6 light years. So because of the fact that is also goes to the star and then comes back. So in total, it traveled 2 times the distance between Earth and the star. So it is 2 times 6 light years divided by 0.8. So because it is the way that is going divided by velocity, it is time, yes? If you divide way by velocity, it is of course the time, so the total time that it will take him is 15 years. So therefore the two twins effectively agree that the twin in the spaceship will be younger when they meet again. In terms of the twin that remains on Earth due to the effect of time. Yes, because of the time dilation. Lengthening and the time lengthening is the reason of the difference between the time that measured by the twin that is on the spacecraft and the time that measured by the twin that is on the Earth. And in terms of his traveling twin is due to the contraction of the distance. The distance between Earth and the star is only 6 light years because the distance is contracted from 10 light years to 6 light years because of the fact that the twin is moving in very high speed. So both of the brothers agree that uh, the twin in the spaceship will be younger when they meet again, and actually will be younger in 10 years. Okay, thank you very much.